So we're going to look at a few carboxylic acid derivatives now. So these are just molecules where we've replaced the OH group with another group. So an ester, which we've just met as an example of that, where we've replaced the OH with an oxygen bonded to a carbon chain of some sort. First group we're going to look at are the Acell Halides. In these we've replaced the OH by a halogen, funnily enough. These are extremely reactive, really useful chemicals, and we are going to have a whole video on these a little bit later on, and how we name them. But just to get you going, we just take the carboxylic acid name and change the OIC to ol, so ethanoyl chloride. Amides. So amides will be coming up in the next topic. So we'll just briefly go through these. In amides, we replace the OH by a nitrogen, and that nitrogen is either just bonded with hydrogens or hydrogens with another R group. There's different types of amides that you can have. They all contain, as you can see, the nitrogen bonded with a hydrogen or a carbon. But you can have primary, where it's two hydrogens, secondary, where they've got one carbon attached, tertiary, we've now haven't got any hydrogens attached, and quaternary is where you have four hydrogens attached. So that would be similar to the situation we have in ammonium, where we've added an H plus to ammonia. And again, we'll look at how these form a little bit later on in a future video. Acid anhydrides, they do scare people a little bit, but there's no need. Just think of them as really reactive acids. They are effectively acids, two acid molecules that have been dehydrated by the loss of a water molecule. We name them from the parent acid, so this one will be ethanoic anhydride because it's come from ethanoic acid. And the way that you can think of them is if we take those two ethanoic acid molecules and we remove that H2O, which is circled in red, so it becomes like that, and you'll be able to see that this is how the molecule is put together.